Hello, in this podcast we're going to be learning about enzymes, and this first podcast about enzymes, specifically we're going to be learning about what enzymes are and how they work. Now, enzymes are a specific form of something called a catalyst, and a catalyst is something that speeds up a reaction without itself being changed by the reaction. And we need very little of it because they're not used up, so they'll be continually reused thousands and thousands and thousands of times. And that's a very good thing because in areas where we use catalysts that are not enzymes, these catalysts can be very, very valuable substances like platinum. And those platinum's actually found in our car in a catalytic converter. And here's a video I want to show you about how a catalytic converter removes the pollution from a lot of the pollution from our car exhaust.
We take it apart so you don't have to. A multitude of cars. In each one, a motor burns fuel and produces toxic gases, nitrogen oxides, carbon monoxide, and unburnt fuel residue. Luckily, each car also has a catalytic converter. Located under the hood, attached to the motor, right before the exhaust system. Gases produced by the motor go straight into the catalytic converter and come out the other side less than 1/10 of a second later. The converter gets less than 1/10 of a second to recombine toxic gas molecules and produce harmless substances like water vapor and oxygen. How? To understand it, we've got to destroy it. The stainless steel housing contains 2 ceramic blocks. Each block is filled with thousands of microducts. Their sides are coated with precious metals. Precious? Platinum and rhodium in the first block. Platinum and palladium in the second block. Metals that can cost more than $100,000 a pound. But they're worth every penny. Together, they have the extraordinary property of causing toxic gases to react and then recombine, producing gases that are harmless to your health. All that without altering themselves or rusting. Precious. The trick is to maximize the contact zone between gas and metals. That's why there are so many microducts, almost 400 per square inch. Their combined surface area matches that of a football field. A laboratory as big as a football field, but folded onto itself in order to remain small. The transformation of gas from toxic to non-toxic happens most efficiently when the catalytic converter is hot. Very hot. 1,300 degrees Fahrenheit. It's the toxic gases themselves that heat up the catalytic converter. They exit the motor at temperatures as high as 900 degrees Fahrenheit. The chemical reactions inside the catalytic converter also generate heat, transforming the converter into a super efficient furnace designed to break down and reform gas molecules. Let's take a closer look at these mysterious transformations. The nitrogen oxide and carbon monoxide molecules, along with the molecules of unburnt fuel residue, enter the catalytic converter. They're swallowed up by the thousands of microducts. As they reach the platinum and rhodium in the first block, nitrogen oxide molecules are the first to react. These metals break down the molecules by withholding one of their atoms. The freed atoms stick to each other and recombine. The result? Nitrogen oxide molecules become oxygen and nitrogen, which already make up 99% of the air that we breathe. The gas molecules now head into the second block, where the microducts are coated in platinum and palladium. These precious metals withhold oxygen. The intense heat here forces the carbon monoxide molecules to combine with the oxygen. The result? Carbon dioxide, the same gas that creates bubbles in soft drinks. Now for the molecules of unburnt fuel residue. At these extreme temperatures, their encounter with the oxygen forces them to recombine. The result? More carbon dioxide and water. All that in less than 1/10 of a second. In theory, the catalytic converter can eliminate 99% of a motor's toxic gases. In reality, it's inefficient as long as it's not hot. A car has to travel about 6 miles before the catalytic converter reaches its ideal operating temperature. That's 6 miles spewing untreated gases. In spite of the catalytic converter's best efforts, the car remains a source of pollution. But thanks to this miniature laboratory, it emits 5 times less pollution. That's still pretty impressive.
Now, as I said, an enzyme is a form of a catalyst. It's an organic catalyst, and specifically it is a protein. And without any enzymes, there would be no metabolism. And remember, metabolism are the chemical reactions that occur in our body. So there'd be no metabolism because the reaction rates would be too low at a normal temperature. Because enzymes, just like all catalysts, speed up reactions. And they do this without being affected by those reactions, so they get continually recycled. And our body, once again, just like in our catalytic converter, the body only needs to make a little bit of it, and that little bit goes a long way. Now, one way you can identify a catalyst in a question is that anything that ends in ase is an enzyme. Like, for example, lactase is an enzyme that digests lactose. And those of you who are lactose intolerant, you no longer make the enzyme lactase, and so that because you don't make that enzyme anymore, you are lactose intolerant. You cannot digest lactose. You cannot turn lactose into you can turn the lactose into glucose and galactose, which are the two sugars that make up the disaccharide lactose. I'll show you a video that shows an enzyme working, and in this what I've done is I've cut an apple in half, and one half I've dipped in lemon juice, and the other half is just going to stay there. And you notice that the one without the lemon juice is going to turn brown, and the one with the lemon juice does not turn brown. And basically because this happens because there's an enzyme, and that enzyme reacts with oxygen in the air, and that turns the apple brown. Same thing happens in tea, and that turns the tea leaf brown, and that makes the color that we like in tea. And the reason why it doesn't work with the lemon juice, there are 2 reasons. One is that lemon juice is an antioxidant, so less oxygen is reaching the enzymes, so the reaction rate is very, very low. And also the lemon juice is acidic, and that also lowers the reaction rate, as we'll see in another vodcast. Now here are the parts of an enzyme, and there are 2 terms here you have to know. There is the substrate, and the substrate is the substances that actually go through the reaction, and they have to bind to the part of the enzyme called an active site. And the active site is the part of the enzyme in which the reaction occurs. And the diagram you see on the left shows more of what a specific enzyme may look like, and you see the active site and the substrate in there. And then on the right you see more of a cartoon version of this, which makes it, I think, a bit clearer. Here you see an example of an enzyme reaction, and you see you've got the enzyme and you've got the substrate. The 2 combine and they make something called the enzyme substrate complex, so you have to know that term, and that is the enzyme and the substrate combined. And when it's combined, that's when the reaction actually is occurring. and then the substrate turns into the products. The products go off, and the enzyme is unchanged, and because it's unchanged, it can meet up with another substrate. While in this diagram that you see here, you see you've got one substrate and it's turning into two products, and this type of thing occurs in your digestive system. It could very, very easily go the other way, because in synthesis, where you take those building blocks and you put them together to make something else, you could very easily have a substrate being two things and the products being one thing. Here are the concluding questions for the vodcast. Number 1, make a box and T-chart for enzyme and catalyst. And in case you forgot, in the box you put the similarities between the two, and in the T-chart you put the differences. So you've got one column for catalyst, another column for enzyme. Number 2, what kind of substance are enzymes? And by this I mean, are they a carbohydrate? Are they a lipid? Are they a protein? Are they nucleic acid? Number 3, what is an active site? And what is a substrate? Number 4, what is the enzyme's role in metabolism? What do they do that lets metabolism occur in our body? What do they do to the chemical reactions? That's what I'm looking for in number 4. And finally, number 5, why do enzymes only work with specific substances? Like, why does lactase only work with lactose but doesn't work with another sugar like sucrose? And that concludes this podcast, and I'll see you tomorrow in class.